Hi, this is going to be the third video in my Munsell Color series. There may be more down the road, who knows, but at least I wanted to get to this third one today, but anyway, this is really this is the one that I hope, in which I will explain in a little more detail the ins and out particular aspects of the Munsell system. Hope you hear me well. I have my microphone right up to my mouth, and my audio seems to be good here, so I maybe I can push it a little bit more. Okay, still no, doesn't seem to do much. Anyway, so Munsell, I wanted to discuss first the idea of how the system was put together. A color wheel is a color wheel. Was invented by, I think, the first one, Isaac Newton, who had the idea to take the spectrum and bend it and to make a circle. And from then on, the idea catch on, and everybody used the same thing. Different colors, different components on different color wheels. Color wheels for painting are different. We know that there's put the emphasis on the three colors: the blue, the yellow, I think, and the red. Whereas for RGB type of systems, additive systems, emissive systems, and monitor systems, monitor displays, it's a different one. Different set of primaries, but Munsell wanted to have 5 primaries. You see, he could have got away with only red, yellow, green, and blue. And you know what? These 4 colors are exactly the what's it called? The opponent pairs colors of the antagonistic system. But he wanted to have a 5th one. It was not complete without it, so he went with 5 colors. And he also went with secondary colors, so 5 primaries and 5 secondaries, if you will. And then in between we could as well intersperse other colors. But in the base idea of a system was it was a decimal system. I think at the time, as I read, he was influenced by a guy named John Dewey, who was a librarian. I think you may have stumbled on the Dewey system if you went to your local library at some point in time many moons ago, because most libraries have switched to the Library of Congress classification since then. But John Dewey at the time, at the turn of the century, 19th century, I think was influential. And you see, to the point that Mr. Munsell was influenced by him and tried to force the system to be just like the Dewey system, with 10 components. And of course, what's important in the Munsell system is the fact there's a neutral scale, not just hues around a circle, but the center of the wheel implicitly is considered neutral. Now, what's interesting in this case, and it gives rise to many subcolors. You can see here I am on 5Y, which is always the maximum. The number 5 is always the maximum of each hue. So the purple is the maximum, blue is the maximum here of this primary. I know it looks greenish, but that's considered blue in Mr. Munsell's system, and so on and so forth. And it progresses always. When you see the Munsell's color wheel presented, by convention, the red should be at the top, and it should proceed this way from left to right. Goes this way, and I think if you look at a lab system, it's very similar. Yes, it's just inverted. Actually, yellow is at the top, but anyway. So what's the point here is that Mr. Munsell added in his head some ideas about what combination of colors were harmonious for him. Remember, this was the 19th century, 1908, 1910, 1912, and so on. and there was no Pantone system at the time. Maybe there should have never been a Pantone system, but that's another story. So what Munsell did is he identified certain combinations, and the natural combinations he identified were, of course, the combinations that involve the colors that are directly opposed on his color wheel. Now, this is a feature that we find in every color wheel, but are the opposed colors on those other color wheels necessarily harmonious? That's another discussion. And what Mr. Munsell here posited, or at least postulated, that the opponent colors here, the colors that are opposed on the circles, would lead to what he calls an harmony of color. So we get harmony 1, we get harmony 2. We see a lot of yellows opposed and presented in the context of blue. We could look at a series of images, but I'm going to leave just with chips at this point. We see orange with blue. Orange with blue is very popular. We see red with blue-green. That's a striking combination, but it's a very appealing visually, in my opinion. And the green with the red-purple is also very popular, but let's see. Well, the interesting also is not only that the hues in the pairs are the fact that they're opposed are interesting, are worth exploring, but there's also a whole, space from top to bottom. So for instance, over here I have two pages of the Munsell book that I have placed in chips and assembled at the center, and we have here a grayscale. It's the value. So if I unlock the layer in design, you can see that this is N9, 9490. You see underneath it has a LEB color. The L is 90. It goes very well. Actually the L scale, the L star scale of the C-Lab system was predicated on Munsell value scale. Why? Because why reinvent the wheel? If Munsell had correctly identified equal perceptual steps of lightness and designing his value scale, why couldn't that work as well for the LEB system? So that's what they used. So we have here the neutrals chips in the center, and on each side we have the hue chips. So BG is for blue-green, and red is for, well, red. 5 is the maximum of the red color, and 5 is the maximum of the blue-green color. So we are where? Where are we? I think we're not here. I think we're here. You see, we're exploring the red blue-green combination. That's what we're doing here. So now what's interesting is that, let me show this line, is that now we can proceed to experiment with any of these colors. So let me start here. First, grab this end of the circle. So why couldn't I use this color, and why couldn't I stay here? If I stay here, I stay in this side of the leaf, and I'm only comparing or opposing colors that are in the same hue. That's not very dynamic. So let's cross the boundary, let's cross the grayscale boundary, and let's go on the other side. So here I'm opposing this blue-green to this red. Notice the number of steps. Now there's different ways that can be done. I can oppose, you see, very little saturated reds to very saturated green. But I could as well oppose sort of equal intensity of saturation on both sides of the grayscale. This is another beauty of the Munsell system, is that allows this fine decomposition and use of this space. Now remember that every step here along the way up and down is supposed to be constant in terms of perception. This was a feature of the system that was worked and pushed in the 40s or in the 30s by the Optical Society of America, and so they have perfected the appearance of each chip so that it indeed appeared to be equally stepped when observed in pairs under a light. So let's go over here. So we can make this. We can make opponents or contrast of two different colors on the same value scale. See, we can go higher in value. We can go higher in value, lighter shades of the two colors on each side, or we can go darker shades on each side, and we can oppose exacting content in terms of the saturation or the chroma, as Munsell called it. You see 3 steps. It's actually called 6 in chroma because it works in steps of 2 of chroma. So we're at chroma 6 on this side on the red, and we're at chroma 6 on this side in the green. Then this, the first number, the green is here, 2, 4, 6. And the middle is 0. So now that's one way of combining colors. Now what about the fact that we're not combining, let's say, equal weights? So I'm combining something very saturated on this side with a rather lightly saturated color on the other side. You see, that's one possibility in terms of combining colors according to Munsell. Now another possibility, which is very interesting, is this one. What if we go in different, change the value as well? In other words, we're into the solids and we're putting a lighter shade of green with a darker shade of red here. See, that creates a very different contrast as well. So and it's the same idea. So now let me see, I can maybe so we have these two. We can make different all kinds of combinations of paths around the Munsell solids. I don't know, I think I have the other pages here. Let me see what the other pages look like. This the other pages should all look the same. What about this one and this one and this one? So we're going around the Munsell pages. So every time we're opposing two colors that are diametrically opposed on the color circle, color wheel. Just wanted to give you an idea. You see the YR, the yellow red, sort of orange. It's interesting to oppose to this blue over here. Imagine to have these two chips like that. I'm just going to move them around just to show you what it looks like. We have them side by side. You see how these two colors, at least as far as I'm concerned, they don't create something unpleasant visually. It's, as far as my monitor is concerned here, I consider this pleasant visually. So that's the idea, one of the idea behind the Munsell's system. Let me see, do I have other interesting color combinations? We're going around the circle and we find now we're getting into the greens and the purple. The greens and the purples are very, very popular. Just take these two colors for instance, and you can see that these are used everywhere. I wouldn't say everywhere, but quite a bit in interior decoration, because they're a pleasant combination of color. It's got to be considered harmonious. So let's see, if I go back to this document, I think I can navigate to the following pages. This is one study of the chips, of combining the chips. And over here we have what's called dyads. it's in French, dyads, so it's opposed colors of equal value and chroma. So this one is like 5R, 5 red, 3 in value, 6 in chroma. See what it gives? And same thing over here, the blue-green, equal value, number 3, value of 3, and equal chroma of 6. So this is it, 5BG 36 and 5BG 36. Now, in this exercise, what I wanted to do was to show the interaction of the color and the background. The fact that when the color is laid out on a dark background, there is certain kinds of, visual dynamics going on with the chips. It's the effect is different as the background color becomes progressively lighter. At some point, it's just the two colors that are, strictly creating the dynamics. Here, it's on an N2 background, N5, N8, and this is an N10. It's a like white background. Let me see if I still have the swatches. Just to make a quick point, let's see here. We have 3 and 6, and we have on 5R and 5BG. So let's see, we can pick 3, 6. Let's see if we can pick a higher color. Let's see, 5, 12. 5 is the value 5, and 12 is the chroma. So let's change this to 12 and just change this to 5. Now what about here? We still want to stay on the BG. See, it's very interesting because the contrast is changing because of the fact it's the same two colors, but because we have different values. Now it's a different sort of a dynamic. It's a different harmony. It's a different effect visually. But let's see if we can lighten this at the same time. Let's go 5, 10, same value, but 10. We don't have a 5, 12, I think, on this blue-green, which is one thing that's always a problem whenever we work with these chips. 5, 12 and 5, 10. We don't have here a 5, 12. No, we don't. See, it's very interesting. So let me see now, go to the next page, see what I have. This is two other colors. This is these two, the green yellow with the paired with the purple. These two colors at the bottom. See, they're opposed. Now let's go to the next page. Now we have here blue and yellow. Blue and yellow. Blue, this is the blue, this is yellow. In this instance, they have a higher value. They're both the value of 6, and they're both with a chroma of 10. This is very easy to make these experiments with the computer because all the color palette is here. You just have to pick and drag a color on top of, to change it, and it's very easy within design. Or you can select an object and just give it a different swatch in the swatch palette. See, it's very interesting. Now let's go see the next page. Next page is YR and blue. This is I like these kinds of combinations of colors myself. I find them harmonious. This is red, purple, and with green. We're getting into interior decoration. Again, this is just green, yellow, and purple. This is yellow, red, which is kind of an orange, with blue. Munsell's blue. And here we're experiment with different value. We're at value 7 now. Again, another page, and another a couple more dyads. These two, see, it's interesting because I'm opposing the purple blue. I'm opposing a very low value with a very high value. The chroma is unequal. There's a difference of 2. This is 10 chroma, this is 12 chroma, but you can see it's a pretty powerful combination. And we're back over here, and we're exploring sort of colors. Blue with yellow, red, and over here what we got, same thing, another combination. And over here what we have is interesting. We got what Munsell calls a sequence of colors, and colors that are made of opposed value, opposed chroma, opposed color, opposed hues, the red and the blue-green, but we have different chromas, 4 over here and 4 actually same, but we have different values. And what's happening here is that we're going at an angle through the solids, because we're going through this gray which is in the center. So let me show this graphically quickly if I can, by going to this page. Let me get the spread. Sorry about that. We want the spread. And where's our little line? It's got to be on the next page. Where's our little 5R? Maybe I should go to the next page. There we are. So we have over here, we have 3, 4 and 7, 4. 3, 4 on this side. So 3, 4, you see, is in between. 3, 4, about here. 3, 4, and we have 7, 4. This is really indeed 3, 4. This is 3, 4. 5R, 3 value 4. 5R, 3 value, and 4 in chroma. Sorry, it's this color, this guy. And on this side we have, sorry, my memory is failing, 7, 4. So 7 is this is the 7 value, and 4 is over here. So we have, you see, these two chips, this chip and this chip, and they're going through the center of the solid. The center is called N5, and the fact that they are going through the center has very big importance for Mr. Munsell, because he considers it then to be very harmonious. And as far as he's concerned, for the eye, for instance, to go from this chip to this chip to this chip to this chip, you see, each of these steps becomes effortless, because there's a progression, numeric progression. We go from 5R3 to 5R4, so one step higher in value. And when we get to number 5, we get one more step in value. And when we go to number this color, blue green, there's one more step in value, and there's one more step in value over here, while there's 2 steps in chroma, 2 step in chroma less, 2 step in chroma more, 2 step in chroma more. You see that? That's a beauty of the system. We couldn't do that with any other system. At least we can do that with the Pantone color system. Forget it, because Pantone 195 to 186 to you know, there's no relationship. That's the problem. That's what the problem I see. Anyway, number 16. So we have here 2 more sequence of different values and different chromas that are going through N5 again. You see that? Look at that. Effortless visually. Look at this. Effortless. It's a little stronger, because we're ending onto more saturated or colors. Now what about this page? Same idea. We're going through not necessarily all in N5, we're going through N6, but we're going in big steps here, from 12 chroma to 6, and 6 to 0, and then we have to go back to with 6 more on the side and 6 more on the side to create the essence of constancy. What about the last page I have here? Another page. It's the same idea. Okay, I'll leave it at that, because I want to get to the last page. And this is same idea. You know, red, purple opposed to green, and we launch from 4. We progress by 1 in value. We progress by 1 in value again. Progress by 1 in value, and you see now this is an unequal chroma on the side, in the sense that we go from an higher chroma to a lower chroma. more saturated color to a less saturated colors, and we go through N7. Here we go through N6. Here we go through N5. So there are different movements up and down inside the value, inside the system. Let me show you now the last one. The last one is interesting because it demonstrate what Munsell calls an elliptical path. Boy. And we start with color 1, and then we go to color 2, color 3, 4, 5, 6, 7, 8, 9, 10. But you see now, as we travel the system, we're going from one end, where the yellow goes very away from the center, has a higher chroma, and when we get closer to the center, we visit these hues with lower kind of chromas, where they're closer to the neutral scale. So let's see if we can understand this, because this is tricky. 14. So every one of these chip corresponds to a different hue. So we go from yellow and counterclockwise to yellow red to red to red purple to purple to blue to blue here, blue green, green, yellow green, and then we end up in the same place that we started with. You see? Now what's interesting is that we have to do this so that then not only there's the scale is constant in value as well. So we see we start from 8 in value, we go down 1 value to 7, and then we go down 1 value to 6, and 1 value to 5, and 1 value to 4, and 1 value to 3. So you see we're going to lower and lower color, being darker and darker, and on the other side we're going back up. So we're going to from 3 to 4, 4 to 5, 5 to 6, 6 to 7, and 7 to 8. So it's an interesting movement in terms of 3 dimensions in the third dimension. And at the same time, we have to be careful to have constant chroma steps. So 14 goes to 12. See, it's a step of 2. Now the next one has to be 10. The next time has to be 8. The next one has to be 6 and 4. See, to have a step of 2 plus 2 plus 2 plus 2 plus 2. Now what about the other side? Well, if we decrease the chroma on this side, we have to increase it on this side. So this is from 4 to 6, 6 to 8 to 10 to 12 to 14. See, it's the same step everywhere. So when we explore this scale visually, it's very harmonious according to Mr. Munsell. Well, that's it now. I think I've covered pretty much what I wanted to cover in this video. Hope it helps you. Thank you for watching.